Alright, g'day guys, let's see if we can get a bit more maths done. This is a question that I was asked on Edmodo, exercise 6H3. Don't have a stylus with me, so I might have to do a bit of typing and a bit of persevering with my drawing with a mouse, which should be interesting, but we'll give it a go. Let's hope it helps. So we've got a rectangular plot enclosed by 200 metres of fencing and it has an area of a squared. First thing we have to do is show that the equation for a can be written in terms of x only. So how do I go about doing that? Well, let's call the other side y. And right now I've got an equation for the perimeter, which would equal 2x plus 2y. That should be easy enough. Now we know the perimeter is 200. So 200 is going to equal 2x plus 2y. You can see 2 is a common factor of every side. Let's simplify that a little bit. 100 is going to equal x plus y. And now you can see in the area formula that they're asking us to find, we've got to have it in terms of x only. So at the moment, I would say the area of a rectangle with one side x and the other side y is xy. I'm going to need to replace y in that. So let's use this perimeter equation that we first came up with to get y in terms of x. So if I subtracted x from each side, I get y equals 100 minus x. So we come over to our area formula and we say sub 100 minus x for y in, well, I don't really need to say what it's in because this is the area. You'll notice that I have to look down to type. I'm not quite as skilled as most of you guys are. Alright, so therefore my area, and I really want to be cool, I can write it in terms of x, is going to be x multiplied by 100 take x. And you can see they've got it in the expanded form, so let's finish it off nicely. Area in terms of x equals 100x minus x. Ah, it did it for me, that's good. 100x minus x squared. So that's part A done. Now, show that the area is maximised when the rectangle is a square. So for part B, what we're really looking for is, well, I want to first of all show when the area is maximised. This is a parabola, it's a sad face parabola. If we have a look at that, we could even come up with a bit of a sketch of that. Here goes my beautiful mouse drawing skills. We can see back here we've got the intercept form there. Oh, that's not too bad. We've got one intercept would be 100 and the other intercept would be 0. Now of course you're going to label your axes. I'm going to have a little bit of trouble doing that with the mouse, but I don't want to get in trouble for doing the wrong thing, so let's call that y, that x, and of course this is my area, so really I shouldn't have called that y, I should have called it A for area. So area, and here's the formula, area equals 100 x minus x squared. So the maximum area is going to be at the turning point, but they're actually asking it to show that when the area is maximised, the rectangle is a square. Well, at that maximum, we know by the property of symmetry that the turning point is going to be halfway between the two intercepts. If one intercept's 100, the other one's 0. Halfway between 100 and 0 is 50. So I could then, use a little sketch, do that, and then say, therefore, max area occurs when x equals 50. Therefore, y equals 50. So the shape is a square. That'd be one way you could do it. What would be the other way? You could find the x coordinate at the turning point. X coordinate of the turning. That didn't do it for me. Let's try that again. X coordinate. Here I go. Control Shift minus. Does it give me subscript? No, it doesn't. Oh well, that's a bit different. Control Shift plus still worked. Control Shift minus not as forthcoming. Oh, I'm sure I could do it somewhere. Let's just call it x bracket TP for now. X coordinate the turning point. We know it's negative b divided by 2a. Now that doesn't look very pretty, does it? I don't like using those non-horizontal vinculums. So let's insert it as an equation. And here we go. We can get to my equation tools, put in a fraction. So here I've got negative b divided by 2a, which in this case, well, a is -1 and b is 100. So I've got another fraction to insert. Get my design tools back out. There's the fraction. So we've got -100, because b is the coefficient of x, divided by by 2a, which is 2 multiplied by -1. Now usually it wouldn't work across the page, but given my computer issues, we're going to today, and you're just going to have to live with it. So -100 divided by -2, we get 50. If they actually asked us what the maximum area was, 50 by 50. 2,500 meters squared. Of course, the other way you can do that is just find the y-coordinate of the turning point. Do you remember how to find the y-coordinate of the turning point? I am going to just include it anyway, because I know this is something that not many of you got last year, and you're probably not that familiar with yet. And it's the more you see it, the more familiar with it you will be. That's what I was trying to say. So 4ac minus b squared. Didn't quite do it. Oh, I see, it made all of it. When I'm in the equation tools, I have to do it this way. 4ac minus b squared divided by 4a. And if we calculate that, we should also get 2,500. So let's see if that is the case. 4ac, well, we've got c equals 0, so that sort of disappears. We've just got negative, b was 100 squared. Oh, come on, slacker. Put the proper thing in there, Chewy. I'll get faster at this. I'm used to just writing these days, so a bit slower at this than I'd like to be, but I'm sure you'll cope. Just a little bit of it there. We can just... come on. Delete that bit. -100 squared. Yay. Notice that it's negative b. Well, why am I squaring? Oh yeah, that's 4ac minus b squared. That's it. So it's negative b squared. That's what we wanted. Divided by 4a, which is 4 multiplied by coefficient of a is just -1. Oh, already got the bracket in there. -1. So I've got 100 squared, negative 100 squared, so -10,000 divided by -4, 2,500 meters squared. And you're done. Didn't like the meters squared. Got to finish it off. We got this far. Meters squared. Hopefully you stopped watching before you saw all those botched efforts, but either way, that's the way you do that one. Good luck with the rest of them. Cheers.